All right, we're going to continue on. We've been looking at some payroll examples. Can somebody tell me how many of these did we do last time? Was it 6? Okay. Then what I'd like you to do is to take your last console app, which was probably Payroll 5, and copy that and make that into Payroll 7. Now, once you've done that, hopefully you've gotten the chance, bring that solution up, so your Payroll 7. And if you remember, one of the things that we had in there is you had 3 different variables. In other words, you had a variable in there that was called hours worked, you had one called hourly rate, and you had one that was called gross pay, correct? We're going to redo this so that you don't need those 3 variables. Rather than using those 3 variables, we're going to use 3 different arrays. So if you go and find those variables, we're going to replace those variables with what you see right here in blue. So you can remove the variable that's called hours worked. You can remove the variable that's called hourly rate. You can remove the variable called gross pay. And you can replace them with this. Now I did put, if you look up on the screen here, you may or may not have this. I created a constant called total employees that I set to 10, because I'm assuming we have 10 people that we're going to enter in information for. All right, so here's my constants up at the top of the screen. Hopefully at least you have all of the other ones. So again, I'm assuming in this particular example that we have 10 employees, okay? You'd have to adjust that accordingly if you had more or if you had less employees than that, all right? But like I said, I want you to come in here. So what this is doing, what you see in blue right here, is that is creating 3 arrays. These are going to be, if you remember this from, you had a test on this a couple weeks ago, whatever it was, these are going to be parallel arrays. So in other words, for each employee, we will be entering in hours, we will be entering a rate, and we will be figuring out a gross. Does that all make sense? But rather than just sitting there and putting it in a loop like that, we're going to be making some changes. Now, if you made those changes up here that I just told you to make, if you removed hours worked, if you removed hourly rate, and if you remove gross pay, down here you're going to have a whole bunch of errors because it references those variables there. And that's okay. All right? But I want you to understand that what you see here in blue, this is creating 3 different arrays. They're all arrays of type double, but now rather than what we did before when we were just handling each employee individually, now we're handling them as a group. Does that all make sense? And that's basically what you do with an array. If you remember, one of the examples that I gave you was I said, imagine, and I used my own case as a situation. Where I live, there are 8 units in the apartment where I live. But if you just put that address down and you don't put an apartment number, probably the mail will still get there and it'll probably still get to the right place. But if you want to be sure, you put in the apartment number. All right? Well, you have to be very precise when you're working with computers. So what this is going to represent, hopefully this makes sense to you, if I put in hours sub zero, so when I put in this, in just a minute, when I put in hours zero, that's the hours worked for the first employee. Rate zero will be the pay rate for the first employee. And gross will be the gross pay for the first employee. All right? So we're going to have 10 employees, and they will be from employee 0 through total employees minus 1, 0 to 9. That should make sense by now. All right? You are going to be working again with arrays when you take the test. I'm planning on going over 3 or 4 examples here today, and then if you want, we can start going over questions that you had at the end of the chapters, for chapters 7 and 8. We can look at some of those also. Planning right now on having the test be on Wednesday, all right, the whole period. Thursday, we will go over chapter 9, which is beginning object-oriented programming. All right. So now when we come in here, notice how this changes. Notice what I'm passing into this for loop. I'm not passing hours worked, hourly rate, and gross pay. All right? I'm passing the hours of the current employee, the rate of the current employee, and the gross of the current employee. Why am I passing gross as a ref? Because look at the name of the routine. Calculate gross pay. All right? So I'm going to be inputting here, I'm going to be inputting the hours worked, and I'm passing hours, and I'm passing it as a ref because I'm going to be changing it. When I call input hourly rate, I'm passing it as a ref because I'm going to be changing it. But now in calculate gross pay, I am not changing the hours, and I am not changing the rate. I'm not changing either one of those. So they're not passed in as ref variables. Ref, remember, reference, so you're passing in the address. But for the other things that are in here, all right, the gross, the total employees, and the total payroll, they're all being passed in as ref variables. And if you look up on the screen here, hopefully this makes sense. These two variables that you see in blue, remember the word we used before, accumulator? Those are both accumulators. I'm accumulating the total number of employees, and I'm accumulating the total payroll. And that's right here. The other thing that you have to get used to doing, and I see some of you do this, and I know it's not like you're trying to do something wrong potentially on purpose, but total employees should never be a double. Why shouldn't that ever be a double? Because you can't have part of an employee. Well, what about part-time? That isn't the same thing. They're still an employee. So you really should strive to make these data types reflective of what they're holding. Payroll, it's a very good chance it'll be dollars and cents. So we make that a double. Total employees, int. It just makes sense to do that. All right? So again, in this for loop, when we're setting the hours worked, it's a ref. When we set the hourly rate, it's a ref. When we set the gross pay, gross is a ref, and our two counters are a ref. And in our display inputs and outputs, neither one of these are refs. Why aren't either one of those a ref? Or why aren't any of those three a ref? Because we're not changing them. And again, notice what I'm trying to do here. I'm trying at least to come up with method names that are reflective of what I'm trying to do. So if we've got a method name called display inputs and outputs, that's what it's doing. Calculate gross pay, that's what it's doing. Input hours worked or input hourly rate, that's what it's doing. All right? If you do that, then you probably aren't going to be required to put in as much documentation. If you use variable names and method names that are reflective of what it is you're trying to do, your program becomes more self-documenting. when we get into on Thursday, when we start talking about classes, class names should be self-documenting. If I've got a class I'm going to create called person, all right, then it should be something about people. So if I'm going to put in height, weight, eye color, hair color, person would be a name that would make sense. I wouldn't call something employee if it was height, weight, eye color, hair color, because that really doesn't exactly make sense. But as you'll see, we can make a class called person, and then we can make a class employee, because an employee is a type of person. We'll get into all that stuff later on this week and next week. All right, in the same way, when we display the final totals, not refs, we're not changing them. Notice that everything here, if you look up on the screen, everything here in blue, except the two accumulators, has got an LCV by it. What that means is the current array element. All right? Then when we get down and look at these, you look at you go, wait a minute. You've got display, inputs and outputs, okay. And here you're passing them all as LCVs, and in here you're not. Why is that? Because anytime you see this, every single example that you see in here, all these, I am never passing the entire array. I'm passing an element of the array. It's more or less, look at it this way. Let's say I was figuring out all of your grades in here. I'm not passing in all of your names. I'm passing in amines, then I'm passing in Ethans, then I'm passing in Ivies, etc. That's what we're doing here. And you have to understand that. If I wanted to be able to work with the array at one time as a whole, then I'd pass in the entire array. But when I pass this in, if I pass in just an array element, all that is a variable. So by default, it's passed in by value. So if I want to change it, that's why I need to put ref in there. All right. This didn't have to change. None of the rest of your stuff in here has to change. This is done the exact same way it was done before. This is done the exact same way it was done before. Put this on a new line. Boys, it kind of runs off the screen. All right. This is the same. This is the same, etc. I'm still doing the same stuff. So if I save this and I run it, all right, please enter hours worked. 40, 10. There's my information. Please enter the next one. Now, what I could have done in here, this is not on my program, but see this where it says please enter hours worked. All right. If I would have wanted to, I could have passed in that loop control variable value. It might have been nice to say please enter hours worked for employee number 1, then employee number 2, etc. That might have been a little nice thing to do, but I didn't do it. All right. Does what's going on here make sense to you? It's Monday, I know. Does this make sense to anybody? I mean, you're always good at answering questions. Does it make sense to you?
Some of it does.
Some of it does. Okay. Because there's two ways that you can deal with an array. You can deal with all of the elements in the array at one time. If you want to deal with all of the elements in the array at one time, then you pass the entire array in. We want to deal with the elements one at a time. We have 10 different employees. So this is going to, for the first time through, this is going to allow us to input the hours worked for employee 1, then employee 2, then employee 3. Bless you. This is being called 10 times. This is being called 10 times. This is being called 10 times. Once for each employee. All right? This, and I'm going to ask you if you can tell me why. So each one of these are being called 10 times. This is only being called one time. Why is that only being called one time? Because it's not in the loop. This is telling it to loop from 0, less than total employees. If there's 10, that's 0 to 9. So this is happening 10 times. And each time through, I'm passing it that current employee. That's what the LCV means. When I handle all of them, then I call this, and I pass my accumulators. And I pass my accumulators in here, because that's where I'm filling them up. So I'm filling them up 10 times, but here it's only once, because now they're filled up. And I just want to display them. So I didn't run the 10 times, but let's just quickly do it here. So 40, 10, 400, 30, 20, 600, just so you can see how it goes all the way through here. 60, 60, you can see 4,200, the person got their overtime pay. 25, 25, oops, 25, 625, 40, 10. I'll just put in a bunch of 40 10s here just so we can finish filling this up. All right, there's our total number of employees, and that's our total payroll. So this was called after all 10 of those employees were filled in. Does that all make sense? All right. We could have done this without an array. Probably it would have encountered us writing more code. You typically write arrays so that you're able to use something as a unit. That's exactly what we're doing right there. All right. Now, when we do the next one, what we're going to do, we're going to look at a GUI one, but I don't even think I put arrays in there. Not that we couldn't have done it, all right, but I just chose not to do it. Any more questions or any questions on this particular example? All right, then if you would, go back to the last GUI program that you created, which I think was Payroll 6, copy that, and from that make Payroll 8. And I'll show you the code, but if you look up on the screen here, what I want you to get out of this is in this example, notice what's been added. Counters for total employees and total payroll. So as I start and I put in 40 and 10, you can see what happened. One employee, total payroll 400. Now notice I've got two buttons. I've got a clear individual and a clear all. And if you look up on the screen here, if I click clear individual, all that does is it clears out the hours worked, the hourly rate, and the gross pay. It does not clear out these. If I call clear all, it removes everything. So I want to be able to add in, let's just say 3 employees. So the first one there, I click clear individual, boom, I'm back there. 50, 10. Now notice 2 employees, 950. Which was my 400 for the first employee plus 550 for my second employee. I clear it out one more time and I put in, let's just say 25 and 25. Now I've got 3 employees. The last one made 625. Adding those 3 together, the 625 plus the 550 plus the 400 gives us 1575. Does that make sense? So if you want to implement this particular example, if you want to implement it, think about what you have to do. First thing is I've got 2 buttons. Instead of, now there's 4 total buttons, you only have 3 on yours. So I created another button. All right, I changed the verbiage on here. So one says clear individual and one says clear all. If you're going to do something like that, make it really hard for the person running your program to screw up. or make it as hard as you can for them to screw up. They may screw up anyway, but let's face it, there's only so much, that you can do to try to help somebody. All right, so if we look at this, what did I add? Well, I do have these two counters. I took this directly, if you look up on the screen here, I took that directly from the last example, the console. Those are accumulators. All right, that's my total employees accumulator. And that one is my total payroll accumulator. These are things that hopefully, the more and more you work with them, the more they'll make sense. All right? Yes?
How come those are global accumulators?
Yes. They didn't have to be, but I made them global, so I wasn't passing them all over the place. All right? I will tell you that when you take the test on Wednesday, whenever we said, Wednesday, I guess, there are two problems. The first one is a console, and it's really and truly not hard. If you did any of the examples for, chapter 7 or 8, when they asked you to do those multiplication tables, one of them is very similar to that one. And the other one is kind of a takeoff of what you've been doing on the arrays. But you're not allowed to have any global variables whatsoever. So you're going to have to pass things, and pass them as either a ref parameter or not a ref parameter, depending on what it is you're supposed to be doing. So what I'm going to ask that you do for that one is grab what you did on your test last time, which hopefully now works, make a copy of that one, and start with that. Then you don't have to start all over again. That one is going to be a GUI problem. The other one is a console. Hopefully you'll have plenty of time to finish that. All right? So let me just show you this real quick here. Let's see. So when you look at this, first of all, I'm hoping what I'm about to say to you makes sense. This clear individual, that was my clear. So clear inputs and outputs, which clears all that stuff. We talked about this before. But I'm going to say something to you, and I'm hoping this makes sense. This is clearing out, this button, clear individual, is clearing out this text box, and this text box. And it's putting the focus back here. Does all that make sense? If I want to clear out everything, I still want to clear out this one, this one, this one. But now I want to also clear out this one, and then put the focus back there. Does that make sense? The reason I'm telling you that is the first thing I should do in this clear all is I should call that routine. Does that make sense? All right, so the first thing I should do in my clear all is I should call the clear individual, because it's already done a bunch of the work for me. It makes no sense for me to replicate that code. None. So if you look in here, in clear all, the first thing I'm doing in clear all is I'm calling clear the individual inputs and outputs. Because once I do that, then I only have 2 lines of code in here. So I just added them right in there. Again, this program is done modularly. I broke it down so everything, and I did not call anything directly from the buttons click routines. If you look at my 4 buttons, here's calculate. It calls calculate gross pay. Here's clear individual. It calls clear individual inputs and outputs. Here's clear all. It calls clear all. And here's exit, which calls exit program now. And as we talked about last week, one of the reasons for doing that, and one of the reasons for doing that way, is if later we wanted to add, for example, menus. We looked a little bit at menus last time. Now I can call those routines directly, not having to worry about calling a buttons click event. All right? And I don't know if you've ever heard the word, but what I'm trying to do is I'm not trying to tether my code to a buttons click event. Instead, I'm having the buttons click event call another routine. All right, hopefully that makes sense. But you'll notice, again, we ran it, so you saw what happened. Now, there's still a problem with this program. If I click calculate right now, it blows up. Okay? I don't know if I did it in the last console example. In the last GUI example, we're fixing this. We're going to fix this. We're going to set it up so you cannot put in bad data in our console app. Please watch how that's done and listen when I reference the pages. That's on your test. Instead of having you randomly generate 25 numbers or 10 numbers, it's going to be 10 numbers. You put them in. And it should handle non-numeric input, it should handle blank input, and it should handle input that's out of range. So it should handle input that's less than 0 or greater than 100. All right, so we'll look at that in just a minute. Any questions on this? All right, then if you would, you can close this one out. Go back to the one that the console one we just did, which I think is console 7. Copy that and make that into payroll 9. And I'm not trying to confuse you with make this copy, but I thought that building it incrementally like this would make more sense to you, because it would give us a chance that every time we change something, you could take a look at it and see exactly what changed, how it changed, or whatever. Trying to remember what changed in here, if anything. Oh, I know. Okay. In the last example that we did, in that last console example, if you remember, we created an array, and the array had 10 elements in it. I've gotten rid of the array, and I've gone back to putting those things in there again, because maybe we don't know how many employees we have. Does that make sense? All right, you say, well, you'd always know how many employees you have, but think about it this way. Let's say that I work for an insurance company, and I'm writing programs for an insurance company. I really have no way of knowing in any one given day how many customers they're going to add, how many customers are going to be removed because they went to another insurance company, they passed away, whatever, or how many different customers might change their name, might change their address, might change their whatever. So what I did in this example, you've seen stuff, we've done stuff like this before. I brought back just my variables, the hours worked, the hourly rate, and the gross pay. I still have my counters, but now I've got the ability to run it an indeterminate number of times. All right? So this again, Boolean again equal true, that's a Boolean variable that's going to figure out whether or not I want to run the program again or whether or not I don't want to run the program again. So again, I removed the arrays for this one. So it's just back to the doubles like we had before. All right? But I have my two accumulators. So again, as we said, this is my total employees accumulator. And this one is my total payroll accumulator. That should make sense to all of you. All right? I like to call this my program continue variable. Okay? This is literally going to be a prompt. All right? And this, let's just say answer to prompt. This right here will be the first character of prompt. What prompt will do is it'll come back and it'll say, do you want to run the program again? Y or N, yes or no? We've gone through examples like this before. All right. So those are our variables. We've got hours worked again, which must fall in the range, that's not a 9. That must be between 0 and 84. We've got the hourly rate, which must be between 10 and 100. Those were the constants that we put up here. All right. We have our gross pay, which may be calculated with overtime, maybe without overtime. That's just a shortcut. We've got our total employees accumulator, our total payroll accumulator, our program continue variable. This will be the answer to that prompt where we say, do you want to run the program again? Ideally, they'll put in a Y or an N, but again, we don't know. They might put in the word yes instead of a Y. So we're going to grab just the first character of that prompt. And we're going to check, then we're going to uppercase it and see whether or not it's an uppercase Y. If it is, we want to run the program again. If it's anything other than an uppercase Y, we're done. Does it make sense to you that when we're done, what we want to do, if you look right here, when we're all done, that's when we want to display those final totals. But now we don't know ahead of time how many employees we have, and we don't know ahead of time how many times we're going to run through the program. So, while again, we input the hours worked. This you know, if you're hurrying like heck to copy this down, you've got all this already. You've got every bit of this. Not in the last example, but in the one before that. All that code is in there. What's new is this. We asked you, now we've just figured out, just displayed your information. Now we ask you, do you want to run the program again? We ask you to put in a Y or an N, but we can't account for people not watching and listening to our instructions. So that becomes prompt. Then we uppercase prompt. So if they typed in a Y, it now becomes a Y. If they type in yes, it now becomes this. Does that all make sense? That's what the two upper's doing. Then we're telling it just to grab the 0th location, so we're telling it to grab that. Just that first character. If that first character is not equal to uppercase Y, again equal false, which gets us the heck out of that loop. Remember, and some of you are still, for whatever reason, might be struggling with this line of code right here, this line, where I'm going to put the comment off to the side, this is equivalent to saying while again equal true. That's what that means. All right? Not worrying so much about keying that in or anything else. Does what's going on in here make sense to people? We're doing the same thing in all of these examples. We're grabbing our current employee and we're asking you to put in their hours worked. Then we're grabbing the current employee and we're asking to enter in their pay rate. Then we're grabbing the current employee and we're figuring out their gross pay. If they had no overtime, it's just hours worked times hourly rate. Excuse me. If they had overtime, then we have to figure that out. They get time and a half for all of their overtime pay. All right? Then we display all that information. So we display their hours worked, their hourly rate, and their gross pay. So notice in this example, there's still refs because we're figuring out the hours worked, so we want to change it. We're figuring out the hourly rate, so we want to change it. We're figuring out our gross pay, we're passing in our accumulators because we want to change them. And remember that if I put ref here, if you look up on the screen, if I have ref here, I have to have ref there. You have to. They have to work in tandem. You will be asked to use ref parameters on your test. I would say if you say, well, I don't get them, then I would strongly suggest that you go back and reread Chapter 7 and especially Chapter 8 and take a look at some of the examples that are in Chapter 8. Because there are several programming examples in that chapter that use ref parameters. This doesn't change. So this display inputs and outputs doesn't change. Display final totals doesn't change. Input hours worked, doesn't change. Input hourly rate, doesn't change. Calculate gross pay, doesn't change. That's all the same. But now again, we can use it or have an indeterminate number of employees. So let's run it. So I'll put in 3, 40, 10, that's 400. Yes, I want to run it again. 50, 10, that person got overtime. Yes, I want to run it one last time. 60 and 10, and they got overtime. So think about it. I should have 3 employees, and their total pay should be 400 plus 550, which would be 950, plus 700. So if we did this right, we'll have 3 employees, and 1,650, if I did my math right, will be their total gross pay. So now I don't want to do it again. And there it is. All right. But again, I can run it again. And now with the way that this is set up, what if I only have 2 employees? I can put in 40 and 10, and it gives me 400. Yes, I want to run it one last time. 50 and 10, and now I don't want to run it again. Now I have just 2 employees. So the advantage of this last one is it'll handle any number of employees. All right? Does that make sense? And again, the one that you do for a raise, it's the same one that you've been working on, and it will be the GUI one. I want you to do it as a GUI. By now, everyone who took the test and or took the retest, not or, but and took the retest, so whether you took the retest or not, okay, and for you guys, I don't remember if you did yours as consoles, but if you did, I'd go back and redo it as, even before the test, do it as a GUI. You're gonna have 4 hours to work on this. And considering the one program, literally the one that's like the multiplication table, if you do the ones that are in the book in the multiplication table, you should be able to hammer that one out in probably 15 minutes. And I'm not exaggerating. Which says you've got 3.5 hours to concentrate on this last one. So it should be right, it should be done well.
2.
What?
There's only 2.
There's only 2. You want more? Okay. So I can make a special one for you, and I can put more on there if you want. Yeah. All right. Everybody's cool with having just 2? Probably for your test on chapters 9 and 10, which I know we haven't even started. You're only going to have 1 problem on there. And that one probably will even be a console. All right? To me, 9 and 10 are the hardest 2 chapters in the book. You're like, oh my God, it gets harder than this? It's just different. Okay. All right. Any other questions on this example? Then if you would, please go back to the last GUI that you created, which was probably 8. Copy that and make it payroll 10. And I want to show you, I want to run this first to show you how this one is different before we look at the code. All right? So I'm going to run this, and please look on the screen here. I'm not going to put anything in there. Everybody agree? There's nothing in there. Now notice how it differs. I'm using the try parse in here. It will not accept invalid input. So if I put this in, and if I put in a number that's out of range, it doesn't accept that either. Not only that, I've got it set up. If you look on the screen, this is kind of important. If you look here, if I put in this, that's invalid input, correct? Look at the message. Illegal input. Illegal input. Now look at this message. Out of range input. See the difference? Again, there's only so much accounting for people running your program the wrong way. But I've said your input's out of range. It must be numeric and it must be within this range. All right? So I use the try parse. And before we look at that, I want to go back to your book. And if you look in the book on page 320 in your book, this is a page that if you dog ear the page, you fold it over or write it down or whatever, you might want to do that. You will be asked on this last example, all right? you will be manually putting in numbers, and the numbers must be valid. So they must be numeric. If they're not, it's an illegal input. They must be within range. So if they're negative or they're greater than 100, they're not in range. Does that make sense? You have to handle both of those. This shows you in this little program snippet that's right here how this can be done. So let's play computer. All right? You come in here and you see this is a console example, but you see on the screen, enter your test score. And then it's waiting for a test score. All right? Then you put it in. So let's say that when you do that, you leave it blank. All right? So this, while not int.parseInt, this says while you put something in there that's not numeric, you'll have a write line that says input data was not formatted correctly, and you ask them to do it again. So what you're doing is you're using a loop and you're forcing them to put in valid input. Because as long as they put in invalid input, they're stuck right in here. All right? And if you look here, now you know what an out parameter is. Okay? What we're doing is we're saying, okay, attempt to take whatever they put in there, attempt to take whatever that is, all right, and attempt to grab it and parse it, so take it and put it into a value that you call score. That's what that does, all right? But when you do that, it's going to check score, and if score is not an integer, it's not going to accept it, all right? So I did the same thing as far as using the try parse. Since this isn't a GUI, there's not a write and a write line, etc., but I'll show you the code. What I did was I came through here and I made a couple constants. Did you notice how it either said illegal input or it said out of range input? So I made constants. One that I called non-numeric hours worked, and that's really a crummy name, and out of range hours worked. I should have just called them non-numeric and out of range. So I really shouldn't have those HWs on there. It should look like this and like this and like this. All right, and anywhere I've got an HW in there, that should be removed. Okay, but now look at what we're doing here. Somehow, and again, everybody learns this differently, but somehow this has to start making sense to you. All right? So what are we doing here? We're saying attempt to grab whatever is in our text box and stick it into hours worked. After you take whatever was in there and you stick it into hours worked, now make sure that it's a double, which means that it's numeric. Does that make sense? That's all that this is checking. This is checking for non-numeric input. That's all it's doing. So if it's non-numeric, we're going to call bad hours worked and then return. What does bad hours worked do? Look on the screen. All right, again, I got to remove these HWs, sorry. All right. So what do those do? There's bad hours worked. So this is going to say out of range input must be a number between 0 and 84, and the title will be out of range input. Okay? Then just like we did before, we're clearing those fields and we're returning. And then we're also returning right here. So again, this, the example I just showed you, will be if I do this. That's going to handle that. Look, illegal input, that's that string constant that I told you about. All right? And they can keep doing this, and a program will be happy as heck to just keep doing that. I mean, it's stupid. We could give them a certain number that if they do it wrong a certain number of times, we kick them out or whatever, but we're not doing that. Now, notice if they come in here and they do put in something that's numeric, but it's out of range. In fact, let's look one more time. Nothing in there, illegal input and illegal input. Now, if we put something that's out of range input, out of range input. You should always try to give your user some kind of an error message that's reflective of what the problem was. Again, that's all you can do. If you're writing, you're writing a program for someone. This isn't a game where, if they're stuck in a corner of a screen and they try to go further that way, that you just don't let them because it's not possible. This would be like if that was a game and they were all the way to the right-hand side and they tried to go right, we'd give them a message. It says you're already over to the right edge of the screen. You can't go any further right. All right, that's what we're doing. This is referred to as input validation. It is probably among the most important things that you do as a programmer. All right. And I'm doing the same exact thing. So if I put in this, now notice what changes. Again, illegal input, but 10 and 100, because that's the rate. And if we put in something that's out of range there, again, out of range, but 10 and 100. So this is the same program as the last one, but now when I come in here and I put in a 10 and I hit enter, there's my first employee. I clear that employee. 50, 10. Now I've got 2 employees, and now you can see how my total payroll has been incremented. All right? This is something, again, you have to understand. What we're going to end up doing in a week or so is we're going to come in here and we're going to just use the console example because it'll be simpler. I don't want to keep having you write program after program after program. But we're going to create an employee class. All right, and then we'll look at extending that class. And don't worry about what that means right now. All right? So I can still clear the individual one, I can still clear all of them, and I can still exit. So all that stuff works. So again, what's changed in here is this. I first check in here with an if, and if you put something in there that was invalid, I'm going to return, which means get the heck out of this routine. If I get down to here, please look up on the screen. If I get down to right here, this line, this should make sense to you. I put in something numeric. We don't know if it's within range or not, but we put in a valid value, we put in a numeric value for hours worked. We know that because we wouldn't get down to here if we didn't. So now we have to check here and see if it's within range. So if it's either less than 0 or it's greater than 100 or whatever the heck it was. I guess it's 0 and 84 for hours. All right, so if that's it, then we give bad hours worked. Then if we get down to here, if we get down to this point, line 74, that means what we put in for our hours worked was a number and it was between 0 and 84. We know that for sure. So now we have to do the same kind of thing here, but we're checking to make sure that it's numeric and it's between 10 and 100. So we're doing the same kind of thing. Now, if that confuses you or you're like, yeah, everything's confused me today, I would strongly suggest you go back and take a look at chapters 7 and 8. If you haven't done the homework for 7 and 8, I would look at the problems at the end of the chapter where you do the multiplication table. I know a couple of you even asked me about them. I think you did, Tiff. Are there a lot of those with the multiplication table? Or?
I haven't got to yet. I'm still
Okay.
7.
Okay. But if you do those, that should really help you. The other one I already told you, you're just going to be adding to the program you already have. You're going to have to make some changes to it. But again, if you can finish the first program in a half an hour, let's just say you can. In fact, let's say that it takes you 50 minutes. You still have 3 hours to do the last program. All right? It's going to be working on this array program that we've been working on. All right? So again, I'm going to back up here a little bit. Not that much. Not that much. So in these exercises for chapter 7, fortune teller, admission, maybe it was chapter 8 that had those. I didn't see any in there.
There's a multiplication on the
Where?
page to the left.
Back up a page. All right, there. I would look at least number 6. Create an stop it. Create an application named multiplication whose main method asks the user to input an integer and then calls a method named display multiplication table, which results in multiplying the integer by each numbers from 2 through 10. The problem on the test isn't that different than that one. So if you've done that one and you understand that one, you should be in pretty good shape. All right. Then at the end of Chapter 8, it's too far. Yeah, you're right. There's nothing that I saw in there that, I'm trying to be as much as I can fair, realistic, or whatever. One of the instructors who works at the St. Louis campus, not Evan, but one of the other instructors, called me last week and said, he's teaching the Java class. He's never taught a programming class before, but he knows programming really well, but he's teaching the Java class. And he said he talked to Evan, and at the end of the chapter, he's going over the entire book, which is like 14 chapters, and at the end of each chapter, there's an average of 12 programs at the end of each chapter. And he's like, Jeff, Evan assigns all of them. There's no way in heck my students can do 170 programs. He said, they don't have the time, they don't have the whatever. So I said, so what are you doing? And he said, for each chapter, I'm doing 2 of them with the class, and I'm assigning 2 of them. That's what I plan on doing. All right? So what I'd like to do, we'll take a break, and afterwards, we can do a couple of them from Chapter 7 and a couple of them from Chapter 8, and I'll pick out a couple more, and we'll assign those. All right? So let's take a break. Let's take a healthy break, and come back at 9:15, please.